today's lesson, we are going to look at tension lesson 105. Let us start. This is today's question. It was posted by one of the learners. So we are going to focus on this question specifically. So as you can see, this question, it has all the data needed for us to actually calculate. And then if I remember correctly, the question was calculate the acceleration of the system and calculate the coefficient of the A block. So we are going to look for the coefficient of A block, and then we are going to look at the acceleration of the whole system. There is lesson 101 up to 104 of this chapter. So if you need some basics, it is advisable for you to actually go through those lesson videos. Now let us actually answer this question. Now what we need to do in order for us to actually calculate, we need to draw free body diagrams for each block. Now the free body diagram for A block will be like this. It will be tension, then we have Fk, we have Fg, and then we have normal force. And then for B block, we only have two forces acting on B block. So it will be tension and Fg, which is also weight. So with this free body diagram, we can actually see the forces which will take part in our equation. So looking at A block, we can see that applied force, tension, and kinetic friction will be the actual forces which will take part in the equation. And then looking at this diagram, we can see that the motion of the system will be to the right, and then for the B block will be upward. So we take right as positive, and then we take left as negative. So all the forces facing to the left direction will be negative. All the forces facing to the right direction will be positive. So these are our free body diagram. So let us start with A block. So F net is equals to ME. Then as we said, we have only three forces which will take part. So we look at force applied. Force applied, it's pointed to the right direction, so it will be positive. Force applied plus tension, it's on the negative direction, plus negative Fk is equals to Ma. The equation of Fk is coefficient multiplied by normal force. Now since we have a flat surface and the force is parallel to the displacement, so it means our normal force will be mg. Now concluding this, we can see that Fk is equals to coefficient multiplied by mg. So where we see Fk, we can substitute by coefficient multiplied by mg. So we have force applied minus tension minus coefficient mg is equals to ma. From the diagram, we are given that the force applied is 25 newtons minus tension minus, in this case we know that this is equals to Fk. So Fk, we are given that it's 2.5. So for now, it's okay, we can simply substitute the whole thing with 2.5 is equals to the mass of A block, it's 4 kg, and then acceleration. Now we just need to solve for t. We can simply take this to this side and then this one to the other side. So tension T in this side, it's negative. When you transpose it will be positive T. It's equals to A. For A it's positive. When you transpose it becomes negative for A. And then 25 minus 2.5, it's equals to 22.5. Then we label this as equation 1. From here we need to generate equation 2 from the second block. Our second block is 1.2 actually kg. Now looking at how many forces are going to take part, we only have two forces, which is tension and Fg. Now you need to know that Fg is equals to mg. So where we see Fg, we can substitute by mg. So for B block, it's F net is equals to ma, and then we have tension will be positive minus Fg is equals to ma. T minus mg is equals to ma. And then where we see m, we substitute by the mass of the B block. So it's T minus 1.2, 9.8, it's equals to 1.2 A. Then we can just simplify this and transpose to the other side. Negative 1.2 multiplied by 9.8, the answer is negative 11.76 is equals to 1.2a. When we transpose, we are going to have T is equals to 1.2a plus 11.76. This is equation 2. Now that we have equation 1 and equation 2, they are both subjected to tension. Subject of the formula is T. Then we can just equate the two equations. So this is our equations. So equation 2 is equals to equation 1. Now equation 2 is 1.2a plus 11.76 is equals to negative 4a plus 22.5. And then we need to simplify. We take all the terms with a variable one side, the terms without a variable one side. So we are going to take this term to the other side, and then we take this one without a to this side. So we are going to have 1.2a, since it's negative 4a this side, it becomes positive 4a, it's equals to 22.5, since it's positive 11.76, it becomes negative 11.76. Negative 11.76 plus 22.5, the answer is 10.74. 1.2a plus 4a is equals to 5.2a. Then we need to get rid of 5.2a from a, so we divide both sides by 5.2. So this will get rid of this, or it will result into 1. 1 multiplied by a, it's equals to 10.74 divided by 5.2. The answer is 2.065. When we round off to 2 decimal places, it will be 2.07 meters per second squared. So this is the first part of the question, whereby we calculate the acceleration of the system. So both of these both of these blocks are moving at, actually they are accelerating at 2.07 meters per second. Now the second question was saying calculate the coefficient of the 4 kg block. So this is the equation. Now going back to the question, this is the 4 kg block, this one. So we are looking for the coefficient of this 4 kg block. We are going to use this equation of kinetic friction. Now since we said normal force is equals to mg, since we are dealing with a flat surface, so our equation will be mg. Now we have this, we have this, we have this, we need to calculate this. Our kinetic friction is 2.5. It's equals to coefficient, the mass is 4, gravitational acceleration is 9.8. So we can divide both sides by 4, 9.8. This will get rid of this. Then coefficient, it's equals to 2.5 divided by 4 multiplied by 9.8. The answer is 0.06. Remember, the coefficient of kinetic friction doesn't have a SI unit. That's it for this lesson video. This is Wahula SJ. Thank you very much.